All right, let's learn about rotations. Rotations are where you turn or you spin a pre-image to make a new image. When we talk about rotations on a coordinate plane, the first thing you should know is that if it says graph the rotation and it doesn't say whether it wants us to turn it clockwise or to turn it counterclockwise, the default in geometry is that they want us to go counterclockwise, which is probably because the quadrants are labeled 1, then 2, then 3, then 4. So that'll come up a lot when you study trigonometry more too, that we usually rotate this way. So when we rotate, we're going to just start by rotating this thing 90 degrees. And I would expect that if you rotate something 90 degrees, a quadrant 1 pre-image should wind up in quadrant 2. Now where those coordinates are going to go, maybe you're good at eyeballing that, but I'm going to show you a nice trick of how to get those coordinates exactly. The first thing I want you to do is put your pencil right at the origin, because the origin is going to be our pivoting point. Now if we wanted to turn this, and I'm expecting that to show up in quadrant 2, hold down your pivot point and actually turn your paper so that if this was the new up and down axis and this was the new side to side axis, does that look like it would be in quadrant 2 if this paper was facing the right way? So now if we're picturing that this is in quadrant 2, you can see that point A is back at -2, +1. And so I'm going to write that down in this box. A prime is at -2, +1. When we turn back our paper, that'll make a little more sense. But let's continue doing that for point B. Point B, when I'm looking at it this way, is at -4, +4. And point C is at -1, +3. So I'm going to turn my paper back now and I'm going to plot those points the way I was seeing them after a rotation. So -2, +1. That's where I was seeing that A prime. B prime at -4, +4. And C prime at -1, 3. And so that gives me a good picture of what I was seeing when I had my paper turned. And so that's supposed to look like what this would look like if I pivoted around the origin 90 degrees. Now if you look carefully, if you connected to point A and to point A prime, you would expect to see a nice 90-degree angle right in there, and that would work same for C to C prime and B to B prime, but that's just an easy way on the coordinate axis to get those new points. Let's try the 180. So 180. So you can just ignore all this blue now. I'm going to switch colors even. We're going to spin this thing 180 degrees, which basically means spin it all the way upside down. A quadrant 1, you would expect to see it all the way upside down. Now it sort of looks like it's in quadrant 3. That would be my 180 degrees brings me to quadrant 3. So now if I'm looking at this as if it were in quadrant 3, I'm thinking, okay, this would be -1, -2. -1, -2. B prime. Looks like it's at -4, -4. And C prime, -3, -1. Once you get all of those written, turn back to your original pre-image and let's graph those. So we're going to graph A prime at -1, -2. B prime. And C prime. This would be a lot harder to do if we weren't turning in intervals of 90, 90, 180, 270. But since the X and Y axis are at 90-degree angles, it makes this pretty easy. All right, the last one is our 270. So 270 is a 90 plus a 90 plus a 90, so that's going to go 1, 2, you're going to expect 3 quadrants. You could also think of it as a 90-degree turn clockwise, right? But it does say 270, so let's pivot from the origin, that's our center of rotation, and we're going to turn this until our pre-image looks like it's in the 4th quadrant. So here would be 90, 180, 270, and that's where we want to be. We want a 4th quadrant image. So same thing that we've done before, we're going to pretend that's the 4th quadrant now. Find our A prime. The book has these fancy rules that if you wanted to memorize a rule for how to find each of those points each time you could. I really don't see the point in that when there's this nice easy trick of just spinning your paper. Alright, A prime at 2, negative 1. Did you notice that all of these image triangles are congruent to the original? And what does that mean? It means that a rotation is, and what's the word? Isometry. Rotations are isometries because the new image is congruent to the original.
Our second example is more of a free-for-all because it's not on a coordinate plane, and if we don't do a multiple of 90, we don't have that benefit to think about. So what we're going to do is we're going to try to rotate triangle DEF around point C, and let's do a 120-degree rotation. And if I don't tell you clockwise or counterclockwise, the given is that we are going to go counterclockwise. Now I've already drawn all these circles on here, but in a normal problem you would just stick the point of your compass at the center of rotation and kind of just show where that point F could rotate to, and adjust it and show where point E could rotate to. So these circles kind of indicate as we spin this where each point will stay put. You see that point F will stay on its own circle and point D on its own circle. Now we just have to figure out how far will it move on its circle, and that's where our protractor is going to come in. We're going to do the 120-degree rotation. Let's start with point E. So we're going to take our protractor, always setting up that center at the pivot point, and we're going to put a 0 lined up with point E. Now we need to measure our 120, starting from our 0. We're using the lower numbers in this case, and we're going to put just a mark out at the 120. So that tells me how far point E will rotate around the circle. It'll rotate until it gets to that point. So I'm just going to use this as sort of a straight edge. Point E is going to rotate until it stops right here. And so that's how we can tell that E prime is right there. Let's try point D. So again, we're going to set up so the center is at the center of rotation. We'll line up point D with the 0. Just how I'm holding this, I've got the bottom numbers that I'm using. I'm going to go out to 120 and put a mark right there. And so when D rotates around its circle, it will stop when it gets to that mark. So D rotates 120 degrees, and here's where D prime would be. And by the way, if you drew that angle in, angle DCD prime, that would be a 120-degree angle. That's how this is working. Let's do point F to finish it off. So we want the center at the center of our protractor, the 0 lined up with point F, going to 120 degrees, putting a mark out there. So point F is going to rotate along its circle until it gets to that stopping point at 120 degrees. Point F to point F prime. Let's connect those. Should be an isometry, so we should get a nice congruent triangle. And I would say that looks pretty good. This angle at D sort of looked like a right angle, and it still looks like a right angle. So that's a good sign. And that's how we're going to practice doing rotations sort of freehand. We'll use the compass to make those sort of guideline circles for the rotation. And then we use our protractor to figure out where to stop rotating on those lines.